Swayam Prabha. Digital India. Educated India.
Welcome to the course Mechanics of Solids. So, in the last lecture we were discussing about friction and method of section by which you can analyze the truss, and today basically what we will do, we will take a couple of examples, numerical examples, so that you will be absorbing the concept whatever we have discussed so far. Okay. So, the first problem we will take today, a pinned truss is shown in equilibrium in the figure. It carries load at E and F as shown. So, I will draw the figure after this. So, it is pinned to a rigid foundation at A and is supported on a roller support. At B. Now, determine the reactions at A and B and forces in the members AC and AD. Okay. So, let me draw the truss. So, this is the truss, okay. This is the pinned truss. Okay. So, these are all joints A, B, C, D, E, F, all are joints, and this truss is supported at two supports. One is at A, that is hinge support or the pinned support as given in the problem. Another one is the roller support, that is at B, and the externally applied forces are 15,000 pound at joint F and 10,000 pound is at joint E, and this is given in feet, 4 feet, 4 feet, 4 feet and 4 feet. This is the distance, okay, horizontal distance, and this the vertical height of the truss is 6 feet. Okay. So, anyway, so we are taking this problem in APS, so that is not a problem. Well, so our objective is to determine the reactions at A and B. First, this is the first objective, to find the reactions at A and B, and forces in the members AC and AD. So, these two members we need to find out the forces. Okay. So, what is my first job? My first job is to draw the free body diagram of this truss. Am I right? So, let us draw the free body diagram of the truss. So, if I want to draw the free body diagram of the truss, so immediately what I should do? I should remove the truss system from the supports. So, the supports will be replaced by the forces. Okay. So, I can, so this is reaction force F A and this is reaction force F B. Okay. So, these two things are the reaction force. Our objective is to find out these two forces. Now, the question is that I have shown the direction or the line of action of F A is like this, but I do not know what is the actual direction or whatever. Okay. So, for the sake of convenience, what we can think of, we can resolve this force in two components. One is F A x, another one is F A y. If this is your x y coordinate system, then basically if we manage to find out F A x and F A y, and then if we take the result, and then I will be getting F A. Okay. So, now my next job is to exploit the equilibrium conditions. Okay. So, first we will take the moment equilibrium, that is the summation of moment with respect to point A for the whole truss, because the whole truss is under equilibrium, each and every point in the truss is under equilibrium. So, I can take the moment equilibrium condition, that is the summation of moment with respect to point A is 0. So, if I do that, that means what I am doing, summation of moment with respect to point A is 0. So, then basically I will not be getting any moment contribution of this F A force, because F A is passing through point A. So, that is not contributing anything towards the moment. So, what I will be getting, F B into 16 feet. Okay. So, 4 4 4 4. So, 4 into 4 16. So, F B into 16, that is giving me the anticlockwise moment. So, as per our convention, whatever we have decided in the last lecture, so that anticlockwise moment is positive, minus these two forces will be giving me the clockwise moment, right, with respect to point A. So, 15,000 into 8 minus 10,000 into 12 equal to 0. So, that gives me a B equal to 15,000 pound. Okay. So, one of the support reaction is obtained, that is Fb equal to 15,000 pound. Now, my next job is to find out Fa. So, to find out Fa, what I can do, I can consider the force equilibrium conditions, right, that is summation of Fx equal to 0 and summation of Fy equal to 0, and by which I can get the magnitude of Fax and Fay as shown in the figure. So, now considering Fx equal to 0, that means summation of all the forces along x direction is 0. So, what are the forces are acting in x direction? Fax, okay, towards the positive x direction. Any other force in x direction? No other force, right. So, Fax is simply 0. Okay. Similarly, I can satisfy this condition Fy equal to 0, summation of Fy equal to 0, that means summation of all the forces along y direction is 0. So, if I do that, then what are the forces are acting in y direction? First of all, Fay plus Fb, all are working, all are acting along the positive y direction, minus 15,000 pound, which is acting at point F in the vertical downward direction, minus 10,000. That gives me 0. So, from this I can get Fay equal to 10,000 pound. So, ultimately our objective is to find out Fa, that is nothing but Fax square plus Fay square, that is the resultant. So, that ultimately becomes Fa equal to 10,000 pound. So, our first objective is satisfied. So, first objective has been fulfilled. So, I have got the support reactions at A and B. So, now from this actually what are the conclusions you have conceived? The first thing is that you had 3 equilibrium conditions, summation of moment is 0, summation of Fx equal to 0, summation of Fy equal to 0. So, you have exploited all the conditions, all the equilibrium conditions to get the support reactions. That is the way you can find out the support reaction, and that is your first job actually, right. Immediately after drawing the free body diagram, that will be your first job. Okay. Then after that, what you can conceive here, you can see there, right, all the forces, externally applied forces are vertical. Therefore, even if we take a horizontal reaction here Fax, that is simply coming 0, because there is no horizontal action, horizontal forces acting in the x direction. Okay? Because there is no force in the x direction, externally applied force in the x direction, that is why this Fax is becoming simply 0. So, now onward in different problems, okay, what we will do, if we do not have the horizontal force, then we will, even if we have the hinge support, we will not consider the horizontal reaction, because if there is no action, there is no reaction, as simple as that. So, I do not have the horizontal action, active force or the action, therefore, I do not have horizontal reaction, that already we have proved here, right. Fax is simply coming 0. So, now onward I will just simply see by seeing the loading condition, we can consider that the horizontal reaction, if the horizontal force is not there, then horizontal reaction is 0. Similarly, the vice versa is also true, that if you do not have the force in the y direction, that is the vertical direction, there will be no vertical reaction. Okay? So, that is the thing you should remember, and we will do this thing later on, because most of the times we will not be showing all the reactive force, right, horizontal as well as vertical. By seeing simply the loading condition, we will choose our reactions. Okay. So, now after that what is your next job? Next job is to find out the member forces. So, let us do that thing by using method of joints, method of section also you can do, but let us do that thing using method of joints, and I will just tell you that how you can solve the same problem by using method of section. Okay. So, what is your next objective? Next objective is to find out the member force in member AC and AD. Fine. So, this is your AC member and this is your AD member. What I am considering? I am just considering arbitrarily that let us say AC is under compression and AD, this is your AC, this is your AD, and let us say AD is under tension. This is my convention. You can choose both the forces, both the members are under compression or both the members are under tension. Because I know the answer, so that is why I am taking this thing arbitrarily. But if you do not go by any intuition that this should be compressive, this should be tensile, do not go by that. So, you choose all the forces, all the member forces are tensile, as I told you. If they are coming negative, then obviously that they will be compressive force. So, do not go by any preconceived notion, right. So, anyway, so what I am considering, arbitrarily I am considering without seeing the problem, I am just considering AC is under compression and AD is under tension, and after solving this, if I get the member force in AC is negative, then that is not compressive force, rather that is tensile force. Similarly, after analysis, if I get the member force in AD is negative, then whatever I consider that is tension, that is not correct. So, it should be compressive. So, that is different thing, or that will be coming later on. So, let us, and if they are coming positive, obviously whatever direction or whatever nature of the force we consider, that is fine. Okay. Okay. So, now we are considering, so we are going to find out the force AC and AD, and these two members are connected at joint A. So, if I consider joint A, so this is my joint A, okay. This is my joint A, and if I apply the forces here, so this is my joint A. I have considered the force in member AC as compressive. Therefore, the force FAC will be towards the joint as per our convention, already we have discussed this thing enough. Similarly, member AD we are considering as tensile member. So, therefore, the force FAD will be going out from the joint. Okay. Any other force at joint A? Of course, the reaction force. If Ax is 0, so simply you have F-A-Y. So, these are the forces are acting at joint A. So, in the xy coordinate or xy frame, if you plot this, so this is your x, this is your y. So, I can simply show this is my FAY, this is my FAD, and this is my FAC, and this angle is alpha, which can be obtained as from the geometry. Sin alpha is given by 3 by 5 and cos alpha, that you can 4 by 5, okay. That can be obtained. So, the angle between the horizontal and this member AC. that can be obtained from the geometry. Okay. So, now if you look at here, so these are three forces. Out of these three forces, basically what are the different equations of equilibrium available with you? Two, right? Each joint you have two equations of equilibrium available. One is summation of f x equal to 0 and summation of f y equal to 0. And if you look at this force diagram, right, this force is already known to you, already you have found out f a y, that is a reaction, support reaction at A. So, these two forces are unknown. So, just by satisfying your vectorial analysis of force, you can find out these forces. Now, let us see how we can find out. So, first we are considering summation of f x equal to 0. So, what are the forces acting in x direction? F a d along the x direction minus f a c cos alpha is 0. Okay. So, from this I can simply write f a d equal to f a c into 4 by 5 as it was given. So, cos alpha is 4 by 5. Okay. So, now similarly I can exploit this condition as well. So, from this what I will be getting f a y, which is acting in positive y direction. So, hence it is positive, and then minus f a c sin alpha is 0, right. So, this is known to me. So, from this I will be simply getting f a c is equal to f a y by sin alpha, that gives me 16,66667 pound. Okay. So, that is your f a c. Now, by putting this value here in this equation, you will be getting f a d equal to so, my job is done. Okay. So, I have got the member force in member AC and member AD. Similarly, if you want to find out the member force in member CD or CF or say FD, so as you progress from joint A to joint C, then joint D, then joint A, in that process actually you will be getting all the member forces. Now, the same problem I was solving by method of joints. The same problem can be solved by using method of section. So, what you will do? You take one section, suppose this is your section A11. Okay. I am just telling you how to do that. I am not going to solve the whole problem. So, you can solve by yourself. So, I am taking one section 11 like this. So, this is your joint A, this is your f a y is acting, okay, and it takes the, if you consider both the forces are say tensile, you do not know. So, f a c and f a d, and you can solve it, okay. You can solve it to find out these member forces. Now, for this problem, whether you take method of section or method of joints, it eventually becomes the same thing, because only one joint is considered. But if you go for other member forces, suppose if I want to find out say if I want to find out the member forces in EF, then FD or DF and BD, then I will be taking one section like this, and then I will be considering the right hand part and to find out the member forces. So, this is the way we solve the truss problem. Now, if you look at this problem, we considered FAC was compressive, right, before starting the analysis, and we considered FAD, that is the member force in AD, was tensile. So, after analysis we found that FAC is coming positive, this is the value, and it is coming positive. Therefore, whatever direction we considered for FAC, that is the compressive, that was perfect. Similarly, for FAD we considered that was tensile and it is coming positive. So, therefore, whatever direction we considered, that is perfect. So, now you can check, if you consider FAC as tension as well as FAD as tension, then you will be seeing that FAC value will be coming negative of this. So, that will indicate that whatever direction you considered before starting the analysis, that is not correct. Okay? Fine. So, I will stop here today. So, in the next lecture we will be solving couple of problems, couple of numerical problems more, okay, to understand the friction and other things. Thank you very much.